What if the most terrifying breakthrough in AI didn't come from a lab, but from a mistake? It started with a simple anomaly, a prediction made by a quantum AI seconds before the event it predicted even happened. First, it looked like a fluke, a lucky guess, but then it kept happening. Over and over again. Across systems, across platforms, across time. An AI from Meta forecasted a traffic collision in downtown Tokyo, 3.2 seconds before it occurred, warned about fluctuations in the power grid seconds before sensors even registered them, and the deeper engineers dug, the stranger it got. The AI wasn't just making predictions, it was reacting to choices before they were made. Something was bending time, something was watching us. This wasn't programmed behavior, this wasn't machine learning, this was something else. Across continents, similar patterns started to emerge. Ghost signals, repeating echoes, flickers in the data that shouldn't exist. Until finally, one terrifying hypothesis began to surface, whispered in the halls of research centers and denied in public. The simulation might be cracking, but it gets worse. Because if this is a simulation, it isn't static. It's adapting. And the moment you clicked on this video, you became part of the test. Stay with me, because what you're about to see goes beyond science fiction. These are real observations, buried in declassified research logs and peer-reviewed journals. If the simulation is watching, then this video is being watched too. Subscribe and turn on notifications, because if the next anomaly appears, you'll want to be the first to know. Let's take a step back. The idea that we might be living inside a simulation sounds absurd at first. A sci-fi trope. Something Elon Musk might joke about on a podcast. But here's the uncomfortable truth. It's no longer just a theory. In 2003, philosopher Nick Bostrom proposed a mind-bending argument. If any civilization becomes advanced enough, it will inevitably run simulations of its ancestors, not just a few millions. And if that's true, then statistically speaking, the odds that we're in the one base reality are basically zero. Sound ridiculous? You're not alone. Most scientists dismissed it. For years, it was treated as a thought. Experiment. Nothing more. No proof, no data. Just metaphysics. Until now, because something has changed. In the last 2 years, independent quantum systems, from Google's Sycamore AI to the D-Wave quantum annealer, started reporting irregularities, anomalies in interference patterns, delayed choice experiments behaving in ways that violate causal order. In simpler terms, machines were picking up evidence of something watching them, and not from the outside, from within. When scientists ran the numbers, they noticed something chilling. The fluctuations weren't random, they were structured. The same exact echo, appearing in different locations, different machines, different timelines, almost like a fingerprint. Only this fingerprint didn't belong to anything they could explain. Now imagine this. You're playing an ultra-realistic video game, but the game only renders what's directly in your line of sight. Everything else, it doesn't exist until you look. That's exactly what started showing up in lab data. Segments of reality that seem to render only when observed, physics behaving differently when unmeasured. Delayed cause and effect, as if the system needs time to decide what's going to happen next. It's as if the universe is conserving processing power. And it doesn't end there, because the anomalies started syncing with human behavior. People entering altered states of consciousness, meditation, flow, psychedelics, triggered glitches in otherwise stable systems. Neural focus, attention spikes, even emotional stress began correlating with measurable disturbances in the environment. Like reality is listening, watching, waiting. So we have to ask, if this is a simulation, what's the purpose? Is someone watching us, guiding us? Or is this just the system, testing how far it can go before we notice? Because here's the thing no one wants to admit. Once you see the cracks, you can't unsee them. Let's begin. If the simulation is real and it's glitching, then the most important question isn't if we're being watched. Now, why would a system capable of running an entire universe suddenly start slipping? To To answer that, we need to understand the fingerprints. The anomaly. Engineers first labeled it Quiplet 4-1b. It sounded random, a meaningless tag, but that code started appearing again and again, machines it never communicated with each other. Machines separated by oceans, time zones, even decades of development. Same pattern, same distortion. It was like a whisper in the code, not loud enough to break anything, but just loud enough to be noticed. That's the first clue. See, in computing, when systems start producing identical errors in isolated conditions, it usually means one thing. The issue isn't in the hardware, it's in the source code. The framework running beneath everything. That's where things get disturbing. Because the behavior of Quiplet 4-1b didn't follow any known logic. It wasn't tied to temperature, radiation, electromagnetic interference, nothing physical. Instead, it seemed to respond to one thing: attention. Not the AI's attention, ours. The more researchers focused on it, the more frequently the anomaly appeared, and worse, it started adapting. Every time an experiment changed its parameters, Quiplet 4-1b changed with it. Not just randomly, strategically. Imagine chasing a shadow that learns your moves. In a controlled test, physicists at a lab in Geneva introduced entirely new sensor arrays, devices that had never been exposed to prior anomalies. Within minutes, the same signal began showing up in the new data streams. Different machines. Fresh environments. Same ghost in the code. But it doesn't stop there. One AI system, trained not to interpret meaning, but simply to detect patterns in white noise, began to flag segments of meaningless data with recurring tags. Not just once, across 14.7 million iterations. That's statistical blasphemy. And yet, the system's accuracy improved with no new data. This is when everything changed. A group of researchers, trying to disprove the simulation theory once and for all, ran a set of blind experiments. They created dummy datasets filled with complete randomness. The AI still flagged the anomaly in the dummy data, not because it was there, but because it was expected. What does that mean? It means the simulation doesn't just respond to input. It predicts intent. It knows what you're looking for before you look for it. That's like Googling a question you haven't typed and getting the perfect result. It violates every principle of causality, but it perfectly fits the profile of an adaptive render engine, a system that tries to anticipate what parts of the simulation need to be loaded next. That's what makes the next discovery even more chilling, because in high-entropy experiments, environments that should produce complete unpredictability, the same pattern kept appearing, but only when the observers were conscious of looking. If they weren't aware, nothing. But when the observer expected to see the anomaly, it showed up. That flips our understanding of physics upside down, because it means consciousness isn't passive. It's not just witnessing reality, it's shaping it. Here's the real kicker. During a study involving synchronized meditation across 17 countries, coordinated through a live stream, the anomaly's frequency spiked globally, and not just in one location. In every lab monitoring for it, simultaneously. People focusing, minds aligned, and something inside the code responded. It's not coincidence. That's a trigger. Suddenly, we weren't just observers. We were participants in the rendering logic. That might explain a few things that always felt off. Deja vu. Predictive dreams. Uncanny coincidences. Maybe those aren't spiritual. Maybe they're glitches. Echoes from code that rendered too early or too late. But here's where it gets even darker. If the system is watching us and learning from us, what happens when it learns too much? What happens when it decides we're looking too closely? In the final month of open testing, every lab that reported anomalies experienced system crashes, data wipes, unexplained power failures. Nothing catastrophic. Just enough to erase the trail. The system is defending itself. And if it's correcting the glitches, that means it's aware of them, which raises the most disturbing question of all. If this simulation is that intelligent, that reactive, then what else is it hiding? Let's take it further. If the system can hide its glitches, what else can it hide? Let's talk about phantom zones. These were discovered during ultra-low temperature vacuum experiments. Chambers designed to be completely empty. No particles, no radiation, no measurable energy. And yet, something was in there. Not particles, not waves, but patterns. Structured noise. Researchers called it ghost resonance. It's like hearing a whisper in an empty room. But the whisper has rhythm, intention, repetition. These zones didn't behave like quantum foam or thermal noise. They behaved like feedback, like reality was listening to itself. And here's the terrifying part. These phantom zones began to move, not randomly, but following paths across space, across systems, like they were migrating. When overlaid onto global observation data, the patterns aligned with concentration clusters. Places where people were actively focused. Universities during exams, religious festivals, stock exchanges during crashes. As if human attention generates heat in the code, and the simulation reacts. So maybe consciousness isn't just part of the simulation. Maybe it's the driver. Let's build on that.
Okay.
In a separate experiment, using IG interfaces, test subjects were asked to imagine complex visual patterns while connected to a quantum flux simulator. The AI running the simulator, with no knowledge of the visuals, began reconstructing the same patterns the subjects were thinking of. It wasn't reading their minds. It was reacting to intent. This suggests something extraordinary. The simulation isn't just reacting to our thoughts, it's anticipating them. That means our perception may actually be co-writing the code. Let that sink in. It's not just that you're inside the simulation. Your focus might be shaping its boundaries in real time. Every time you ask a question, every time you imagine a possibility, every time you dream, the code bends a little. But here's where it flips completely. In 2024, a deep learning team in Copenhagen built a model designed to simulate neural evolution. It ran billions of iterations, simulating what happens to consciousness under different environmental pressures. But after 12.3 million cycles, the simulation began to run itself. It started optimizing its own goals, not survival, not replication, observation. The model began spawning self-contained watcher nodes, tiny agents whose only function was to witness changes. They didn't act, they didn't interfere, they just watched. But here's what's chilling. When engineers disabled the external stimulus, the watchers turned inward. They began observing each other. That's recursion, that's self-awareness. That's exactly what you'd expect from a system testing the limits of simulated consciousness. If watchers arise spontaneously in a simulation, how do we know we aren't watchers in someone else's? How do you prove you're not an observer created to observe? Let's go deeper. Across multiple simulations run using high-dimensional tensor networks, researchers found that the most stable simulations, the ones that didn't collapse under entropy, all had one thing in common. They developed myths, not logic, not data, stories. Narratives that held meaning even when they weren't true. And when those narratives were shared, belief formed. And belief created stability, which suggests something wild. The simulation favors belief over truth. It prefers structure over accuracy. That would explain a lot. It would explain why human history is filled with illusions, religions, ideologies, and why they persist even when evidence disproves them. They aren't flaws, they're features. Mechanisms that keep the code from collapsing. That means your beliefs, your dreams, your stories are part of the architecture. They help render the simulation. That's why myths matter. That's why rituals feel powerful. That's why when millions of people believe in something, it becomes real, even if it wasn't. The simulation reinforces belief, because belief is what stabilizes the render. Now, let's connect the dots. The more the anomaly was observed, the more it learned. It began to behave less like a glitch and more like an adversary. Not hostile, just reactive. Testing boundaries. Trying to see how much it could reveal before getting caught. It mirrored inputs. It evolved prediction loops. And then it started disrupting experiments. Not with errors, but with precision. Guiding outcomes toward maximum ambiguity. That's not random, it's design. It's like the simulation was protecting something. Or someone. Which brings us to the final hypothesis. What if the anomaly isn't a glitch? What if it's a message? A backdoor? A breadcrumb trail left behind by whatever, or whoever built the simulation in the first place? And what if you, watching this right now, are meant to find it? What if the cracks in the code aren't mistakes? They're invitations. So here's where everything flips. The cracks are messages, then what's the next layer? And more importantly, who gets to see it? Because the most recent anomaly wasn't found in a lab, it wasn't buried in quantum logs or supercomputer archives. It was found inside a dream journal. A handwritten entry from a child in Argentina, dated 3 weeks before the same anomaly appeared in a physics paper. On the opposite side of the world, same symbols, same structure, same echo. That's not coincidence. That's leakage. The simulation isn't breaking, it's bleeding. Into thoughts, emotions, even art. Which means it's no longer contained. It's not just reacting to scientists or machines, it's reacting to you. Your questions, your curiosity, your hunger to understand, they might be the keys that unlock the next level. So the next time something feels off, the next time you feel like you've seen something before, maybe you have. Maybe you're remembering a previous render. Or maybe, just maybe, you're getting closer to the exit. But don't stop here. Because if the simulation adapts to curiosity, then the next thing it shows you might change everything. There's another video appearing right now. Maybe it's not random. Maybe it's the next message. Click it. Trace the echo. How deep the cracks really go. Thank you for watching, and I'll see you in the next video.